Potential due to a group of charged particles. Let us consider n charged particles q1, q2, q3 dash dash qn are at distance r1, r2, r3 dash 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 rn from a point P respectively. In order to explain this, what I'm going to do, I'm going to consider this information to draw a figure. So here is my point P and I have all the charged particles q1, q2, q3, q4, qn minus 1 and qn. So we have n charged particles right here and they are respectively r1, r2, r3 dash dash rn distance apart. Then the electric potential due to all charged particles at point P is given as V is equal to V1 plus V2 plus V3 plus dash 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 Vn, where V1, V2, V3 and Vn are basically the electric potential due to charged particles q1, q2, q3 dash dash qn at a distance r1, r2, r3 dash dash rn apart from point P. Now let's substitute the values. So if we do that, we will write V is equal to 1 over 4 pi epsilon 0 q1 over r1 plus 1 over 4 pi epsilon 0 q2 over r2 plus 1 over 4 pi epsilon 0 q3 over r3 plus dash 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 plus 1 over 4 pi epsilon 0 qn over rn. Now as we can see, we have 1 over 4 pi epsilon 0 common. So if we do that, we will write V is equal to 1 over 4 pi epsilon 0 common. Inside the bracket we have q1 over r1 plus q2 over r2 plus q3 over r3 plus dash 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 plus qn over rn. Now if we simplify further, we will write V is equal to 1 over 4 pi epsilon 0 sigma I is equal to 1 to n qi over ri, and this is basically the total electric potential due to group of charged particles, which we have n number of charged particles.